Here we go. It's time for Hangprinter version 3, build part 2. So in this video, we'll hopefully get the Hangprinter put up, we'll get it calibrated, and we'll get a first print. I did run the initial build video for Hangprinter version 3 by Torbjorn, and he had a few suggestions. The first one being on the A, B, and C anchors, we need to cut this piece of Bowden tube off flush. This just gives us a more direct path to the mover. So that was an easy fix. He also mentioned that the 12 volt 10 amp power supply was giving him a few issues. He recommended maybe we should go with a 12.5 amp power supply. I'm going to keep going with the 10 amp. If it gives us issues, I'll grab another one. But if you're building from scratch, maybe you should just go with the 12.5 amp at the beginning. Really, the only other thing that is different from video 1 is I'm going to change the locations of the motor cables for these gears. The only difference that this will make is which motor driver is controlling which axis. The only reason that I'm changing these is so the layout of the printer makes more sense. So when we hang this up, this will be the A axis, this will be the C axis, and this will be the B axis. This is the A spool, this is the B spool, and this is the C spool. So really all I did was flip the A and the C spools. And those are all the changes. Now it's time to get it hung up and calibrated. So first, let me give you the lay of the land a little bit. This is the area on the other side of the basement in front of the printer shelf. It's about 20 feet from over there where the table is that you usually see. This is going to be the new home of the Hangprinter. So the A axis will be behind me, the B axis will be over there, and the C axis will be over there. The print area is right here, and the mover will hang right above here. So I moved the camera up a little bit so you can see what's going on the ceiling. The first obstacle is we have utilities on the ceiling that we can't mount the mover directly to the rafters. So what I've done is I've scabbed 4 2x4s that hang down about 2 inches, and then we can put the mover on those 2x4s. Next thing we need to do is we need to get the mover on the ceiling. And my recommendation is go find a friend to help you, because this thing is really heavy. But I'm just going to hang it with 4 wood screws onto these 2x4 pieces. Now the mover is up, we'll give you a shot of that to show you what it looks like. This camera's pointed up at the mover in front of the build area, just to give you an idea of what you're looking at and what angle it is. So this area is the A axis, and it will be pointed this way. B axis this way, C axis that way. So the next thing I'm going to do is I'm going to remove the extruder body from the mover, because we need to use the mover to line up the build plate and get it level. So I'm just going to take the 2 screws out that hold the extruder on, remove it, and set the extruder up here for now. Now I'm going to hook up the power cable and the USB cable to the mover because we need to let some of these lines out so that we can hook them to the mover. So here's the power cable. And I have this really long USB cable that actually hooks into the computer that's over there on the table. I'm going to put a clamp on that so it doesn't get in the way of anything. So now let's take the tape off to our D mover lines. So now we'll head to screen share and open up Pronterface. And let's connect up to the Hangprinter. Now we'll start letting the D lines out slowly. We want to keep track of the D lines while they let out because we don't want them to get tangled. So keep them in your hands as much as possible. We'll do a G6 D100 F500. That will let out 100 millimeters of line at a feed rate of 500. Remember, keep track of your lines. Keep entering that command and go slow until you get all the way to the floor. Now that the lines are all the way onto the floor, we need to run the D lines through this hole and then underneath through this tunnel into the center of the mover. I want my extruder to be in the center of the mover. So I'm going to put the A axis this way, B this way, C this way. So we'll run it through this top hole, then we'll guide it through this tunnel into the center of the mover. So there's one. Now we'll do this for the other 2 corners. Now that all 3 of the D lines are threaded through the top and into the center of the mover, you want to make a loop on the end of each one of the lines. This will attach to the line adjuster. This slides back and forth on the beam. So tie loops on the end of all 3 of the D lines. So there's your loop, if you can see that. And it just goes on this adjuster. Just put all three on the adjuster loose for now. Now we're going to take slack out of the D lines using the software. We want to get the mover floating. So we're going to do G6, D -100, F500. Again, mind the slack on the mover so it doesn't get hung up. We'll do -100 again, and one more time should get us up in the air. Now that the mover's floating and we have one D line per beam, one here, and one here, we can adjust the line adjuster back and forth to set the level of the mover. So we'll get our spirit level out. So this end needs to go down. So we'll pull our adjuster this way. So that side looks pretty good. We'll check it here. That side looks pretty good, and we'll check it here. And that side looks pretty good. So when you're happy with the level, just snug the bolt up on the line adjuster. Just don't snug it up too tight because it is a plastic part. You just want it snug enough so the line doesn't move around. So now that the mover is floating and level, we want to bring it down to the print surface slowly. We're going to use it to level the print surface and to get an accurate area for the print surface. So we'll do G6, D10, F500. As you get close to the surface, we'll switch to D1. Now I'm going to bring the mover up just 1 millimeter. So it's now floating again. I want to let it settle and level as much as possible. When it's settled, you want to mark all three of the line holes onto the print surface. Don't worry about the outline. That's just for reference. But what you actually calibrate by is the holes that the lines go through. So you want these to be as accurate as possible. Mark all three corners. So now we've leveled the bed surface, which can no longer move from here on out, and the mover is level. The D lines are connected. Now we need to start hooking in the anchor lines. We'll start with the A anchor behind me. We're just going to pull the lines down, connect it through the anchor, and then to the mover. So we'll start by pulling all the tape off the A, B, and C anchors. And just like with the D lines, we're going to bring the A lines out until we get to the A anchor. So I'm going to start with G, A1000, F500 because we have quite a ways to go. Remember, mind the lines so they don't get tangled. I'm going to try to get you a shot of this the best I can. But now that you have the A lines pulled out to the anchor, you need to thread the line through the back of the line roller and through the front of the Bowden tube. From above, over the V-bearing, under the V-bearing, through the Bowden tube, all the way to the mover. There's both the A lines pulled through. Now we'll move on to attaching them to the mover. So hooking all the lines to the mover is pretty much the same process as the D lines. You go through the top hole, then you feed it through the tunnel in the printed part. You pull it under the beams on the printed part into the center of the mover, and then repeat that same process for the other A line. Once you get both of the lines pulled through the part and into the center of the mover, we'll do the same thing as we did on the D lines. We're just going to put a loop in each, but both of these will connect to the same adjuster. This is so you can square up the mover on the A side. You can snug it up in software. So loop both these lines. So both my lines are looped and attached to the adjuster, and they got just a little bit short, so I'm going to let just a little bit of the A line out. So G6, A10, F500, and we'll let the A lines out just until the mover gets back to center. And you can adjust the mover how square it is to the A axis by moving this adjuster back and forth. We'll move that a little more during the calibration, so no need to snug it up for now. Now we'll move on to pulling the B lines out. Same process. We'll start with G6, B1000, F500. Mind the lines so they don't get tangled, and move towards the anchor. So now that we have enough line out for our B anchors, we'll just repeat the process. Line comes down from the ceiling, over the V-groove bearing, under it, through the Bowden tube, back towards the mover. We're going to repeat the same for the other side. Now it's hooked into the anchor, we'll continue on to the mover. Same process for the B and C sides. It's just rinse and repeat. Through the top hole, through the tunnel, into the center. You loop it, both sides. Now both the B lines are to the center of the mover. I'm going to put loops on them, and the only difference on the B and C lines is you've got this cross member to jump over. So I'm going to jump over it and attach it to the top of these adjusters for B and C. Both the B lines will go right here. Both the B lines are on. Now we're just going to move ahead and go to the C lines. Same deal, G6, C1000, F500 until we get all the way to the anchor. Mind the lines. Same with the C anchor, from the ceiling, around the back of the V-groove, under the V-groove, through the Bowden tube, on to the mover. Both sides. Same on the C lines, through the top hole, through the tunnel in the bottom, into the center of the mover. C lines are to the center of the adjuster. We'll loop the ends, and we'll attach them to this adjuster. On the C side, again, just like the B side, we'll be jumping over this mount. So this side is going to hook to the top of that adjuster. Now, all the lines are connected to the mover. I'm going to snug them all up slightly. You don't want them too snug, but I want it to get in roughly its final location before we start our calibration. Snug C up, then we'll do B, and then we'll bring A in a touch. And we'll bring the mover up just a little. So now we're going to start the calibration process, and it is quite the process. I'm going to use a builder square as a rough guide to what is straight. You can use pretty much anything, like a piece of shelving, just as long as it's square. So the first thing we're going to do is go around and set all the anchors so they're roughly parallel to the mover. That's where this line comes in on the build surface. It's a little easier to see what is parallel. So just go around and move the anchors for a loose adjustment for now. So the A anchor looks pretty square with the build surface. So now I'll move this beam slider to finish squaring it up. So that looks pretty square. So the next thing we want to do is we want to measure from these dots to the corresponding anchor on the A anchor. So this dot and this dot to the A anchor. I want all my anchors to be somewhat equal because it makes the math a little easier. So I'm going to set all the anchors at a distance of 155 centimeters. So this is roughly 155 centimeters from the point where we marked the hole in the mover on this side and the same on this side. You just want to get these equal. We're going to further calibrate that later, so just rough it in for now. Same with the B anchor. Try to get it as parallel with that line on the base for now, and measure from the anchor points to the points you marked on the build surface. Trying to keep these all around 155 centimeters. This side's good. This side's good. We'll check the other side again, and we're very close to 155 centimeters. Just like with the A side, I'm going to adjust this slider left and right to get the mover a little more square with the build surface. If you have to move your loop, just retie your loop. Before we do the C side, I'm going to bring in a little of the A line. And I'm going to let out a little of the B line. This is just to get us a little bit closer to center. Same with the C side. We'll try to get it as parallel with the line on the bed surface as we can, and then we'll try to get each point to 155 centimeters from the dot that we measured on the bed surface. 155 there, 155 on that side, one more time on this side, and that's looking pretty good. Again, I'm going to snug the lines up a little bit. This just helps me keep track of them. So C -10. Then I'll do B -10, and then A -10. And I'm going to bring the mover up enough that I can get a measuring tape and a couple of lines underneath it. Now we've got all the lines snugged up. All the anchors are pretty much parallel with the build surface, and they're all pretty much the same length away from the build surface. Each point to each anchor point, 155 centimeters. Now we start what I like to call the serious calibration. We're going to run a couple of lines down the center that simulate the y-axis. Then from there, we're going to measure to the points on the anchors to form the Cartesian measurements. I've got a diagram I'm going to show you that might make a little more sense. But first, we'll get the y lines ran. We're going to hook them onto these anchors and run them all the way to the other side of the room. We'll tape them to the floor. I'll show you. These are temporary lines, so I'm just going to wrap them around the line roller, but they do need to be on the same trajectory as your A line. So we'll pull this line out and go under the mover. And we'll continue on in the Y direction. Make sure you get under the lines. Don't run into any of them. You want to try to get this line lined up so it passes the hole that you marked on the mover on this corner. Continue on past the B and C anchors. You want it to pass over this hole that you marked as close as you possibly can, and then tape it down to the floor past the B and C anchors. Now we'll do one on the other side. Repeat this process, only you want it to go over the other A mark. So wrap it around this line roller. Remember, it needs to keep the same trajectory as the A line. We'll bring it under the mover. Get it lined up with the hole as close as you possibly can. Make sure it's past the B and C anchors, and then tape the line down. That's pretty close to where we need the line to be. This symbolizes the y-axis of our Cartesian coordinate system. We need to measure from this line roller to the y-axis line. I've put a thumbtack right here so I can rest my tape measure on it. Take your square and try to line it up as square as you can with this Y line. Now you take your tape measure, you put it against that line roller, and against the Y line, you want to find the spot where is the least amount of distance. Looks like 1,323 millimeters is the spot. Try to keep your tape as straight with your straight edge as you can. Mark that spot with your tape. And it's 1,323 that way. Now we mark from that line to that dot on the mover. Keep it as straight on the Y line as you can, and that is 815 millimeters. Now we do the same for the C anchor. We measure from here over to the Y line. Again, make the tape with the straight edge as straight as possible. You want the smallest amount of measurement. That looks to be right about 1,278 millimeters. So you mark that with your tape. Then you measure from this mark to the mark we just made, and that is 864 millimeters. One last measurement we'll need is how far it is from the print surface to the top of the D idler. On mine, that is 1,980 millimeters. Okay. So there would be only one more measurement, but this would only be needed if your anchors were higher or lower than your print surface. Our print surface and our anchors are roughly the same height, so we're just going to mark those measurements as 0. I'll show you those in a second. Now it's time to take our measurements and do a sanity check on our math. It's also time to do a sanity check on you and me if you've made it this far in the video. Let's head over to the screen share. So this is the Marlin configuration.h file for the Hangprinter firmware. Link in the description below. These are the measurements that you have to enter for all the calibration measurements we just took. This is the best diagram that I could come up with showing you what the measurements were. You have the BX measurement, the BY measurement, the CY measurement, and the CX measurement. The AY measurement is easy. That's just the distance between the A anchor and the mover. You will enter this measurement as a negative value. So I took all the measurements that we took on the floor and I entered them in here. Remember, AY is going to be negative and CX is going to be negative. These all need to be entered in millimeters and you have to have them as a decimal. So 155 centimeters turns into 1550.0. All of the AZ, BZ, and CZ measurements are 0 because there's no difference in between our anchor height and our bed height. If there were, you would enter them as a negative value here. I'll put a link up to this diagram. Hopefully it's helpful. As a sanity check, you can use this calculator to measure the C distance of the triangle, the CY measurement, the CX measurement, and the distance between this line roller and the corner of the mover. If we measured everything correctly, these two lines will equal close to the measurements we set for our anchor locations. That's 155 centimeters for all the anchors. So if you enter 1323 and 815, we get really close to 155 centimeters. If you enter 1278 and 864, 154 centimeters, but that's close enough. Now that you have your measurements in your config.h, you can upload to the printer. Make sure in the firmware you also set up your default E-steps for the extruder that you're using. I'm going to start at 100. Now that the upload is complete, we'll do a couple of quick G1 moves to make sure everything turned out okay. We'll do G1Z50. Everything looks like it's moving correctly. Let's take a look at the ceiling unit, and we'll do G1Z100. You can see all the lines are moving to compensate for the Z move. So the calibration looks good. Now we can slide the extruder back on the mover. The extruder's back on. I'm just going to take all the excess ribbon cable and clamp it up here in the ceiling to get it out of the way. Now I'm going to bring the mover back down to the print surface. I'm going to slack the A, B, and C lines so the mover hangs free. G6, A10, B10, C10. Then I'm going to bring the mover back up. G6, D, -10. I'm going to bring the mover down until the hot end almost touches. I'm going to slack the A, B, and C lines a little more. I just want to make sure that the mover is hanging freely. Now that the mover is hanging free, this should mark the center of our print surface. Now that the mover is hanging freely on the D lines, this should tell us where the center of our print surface is. I'm actually going to print on a piece of plexiglass that has glue stick on it. It seems to hold really well to prints. So we'll slide this under here, and then we'll mark the center of the print surface, right underneath the hot end. And we'll put some clamps down so it doesn't go anywhere. Now we'll set the hot end to 215. The heat is rising, that's a good sign. I'm just going to clamp this 3D printed spool holder to the ceiling plate. And we can load our filament. Now we want to spool up the A, B, and C lines so it keeps the mover in the middle of the print bed. A little bit more in the C direction. Then we'll run a G6, A -0.5, B -0.5, C -0.5 to snug up the whole mover. We want to get all the slack out of the lines. Bring the mover down so it's about 1 millimeter away from the print bed, and you're ready to print. Now let's load some test G-code. I will link this G-code in the description as well. It's just a big tall square. And then we'll hit the print button. You'll want to keep a G6 D negative or D positive 0.5 command ready so you can adjust for bed level. It looks like we're sticking pretty well. I'm going to do a G6 D 0.5 to lower it just a little, and we should be good to go. I'm going to tighten up all the A, B, and C lines just a little with an A -0.5, a B -0.5, and a C -0.5. Looks like we're printing pretty well. Let's take it to the time lapse. And there it is, our first print on our Hangprinter version 3. It doesn't look that great. There were a few motor skips that caused some layer shift, and I did have to try a couple of times before I got it to stick to the bed, but it is a print. We gotta start somewhere. Let's take a look at it. For the first 130 millimeters, the print is looking really good. Way better than I expected. There's a couple things that I wanted to mention that I did during the build. I had to increase the stepper driver voltage up to 0.9 volts to keep some of the motors from skipping. I also route the A, B, and C lines a little differently than Tourbillon does, but it shouldn't make a difference. Remember to snug up your line holders as well. Check out the PID temperature setting for the extruder. By default, this is set for a genuine volcano hot end, so it might be different for your setup. Check out the line buildup compensation setting in Marlin. Mine was commented out. Tourbillon has corrected this in the firmware, but you might also have to calibrate that setting. And finally, when you're slicing your files, consider adding 4 or 5 rows of skirt to help you adjust the printer's height before the print actually starts. A big thanks to Tourbillon for coming up with this whole thing. Please consider contributing to his project. I hope you found this video helpful. If you liked it, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts below, and as always, thanks for watching.